Hello students, welcome to the classes. In this session, we will see few more problems based on the 6 formulae we have derived. Okay, so let's see the first problem. Integration of 1 divided by 3x square plus 13x minus 10 dx. In the problems we have solved till now, x square coefficient was 1, but here x square coefficient is 3. In such problems, what to do? There are two methods to solve this problem. Okay, so we will see one method. Okay, so let's take this integral as I. 1 divided by 3x square plus 13x minus 10 dx. Okay, so what I will do is I equals to, I will take 3 common from the denominator. If I take 3 common from the denominator, inside we get, see here, inside we get x square plus 13 by 3 x minus 10 by 3 dx. Right? It's like what? It is like multiplying by 3 outside, dividing by 3 inside to the denominator. To the denominator, I multiply by 3 outside. Okay. To the denominator, I multiply by 3 outside, divide by 3 inside. Now here, this I need to express in the form of a square using completing square method. So to use completing square method, I write the formula a plus b whole square equals to a square plus 2ab plus b square. Why should I use a plus b whole square? Because coefficient of x is what? Positive. Now if you compare with this formula, okay, I'll just do one thing. I'll call this as equation 1. Okay, so I'll just take this x square plus 13 by 3 x minus 10 by 3. So if I compare here, a square is nothing but x square. I write it as it is. So a is nothing but what? X. Now 2ab, 2 into a is nothing but x, and I should write some term here so that we get 13 by 3. Right. So I have to get 3 here. Right. 2 3s are what? 2 3s is 6. So if I write 6 here, 2 1s are 2 3s are. I get 3 in the denominator. And I should get 13 in the numerator. So I write 13 in the numerator. Now you can see if you simplify, 2 1s are 2 3s are. 13 by 3 x. We have 13 by 3 x. Right. Now this is 2ab term. Now I should add and subtract b square. What is b here? 13 by 3. So 13 by 6. Right. I will add 13 by 6 whole square. I will subtract 13 by 6 whole square. Okay. Then minus 10 by 3 as it is. Minus 10 by 3 as it is. Now equals to, see here, a square plus 2ab plus b square. This is nothing but a plus b whole square. Right? A square plus 2ab plus b square is nothing but a plus b whole square minus 13 square is 169 divided by 6 square is nothing but 36 minus 10 divided by 3. Right. Now here x plus 13 by 6 whole square minus, what is the LCM of 36 and 3? 36 and 3 LCM is 36 only. Now 36 ones are, 3 12s are. Right. Now see here, minus 169 into 1, 169, 10 into 12, 120, minus 169 minus 120, minus 289. Right. Now this we can write x plus 13 by 6 whole square minus, this I can write 17 by 6 whole square, because 17 square 289, 6 square 36. Now this is what? X square plus 13 by 3 x minus 10 by 3. Right. So I call this as equation 2. What I will do is I will substitute equation 2 in equation 1. So here I will write, put equation 2 in equation 1. So what is your I? I is nothing but 1 by 3 outside as it is. 1 by 3 outside as it is, inside integration of 1 divided by. So this term I can express it like this. So this I can write it as what? X plus 13 by 6 whole square minus 17 by 6 whole square dx. Right. Now what I will do is I will substitute x plus 13 by 6 as what? T. Put x plus 13 by 6 equals to t. Right. Now differentiate with respect to x. Differentiate with respect to x. Right. Differentiate with respect to x. Differentiation of x is 1. 13 by 6 is a constant. Its differentiation 0 equals to t differentiation dt by dx. Now dx into 1. So it implies dx into 1 dx equals to dt. So we get what? Dx equals to dt. So what is your I now? I equals to 1 by 3 integration 1 divided by x plus 13 by 6 is nothing but t. So we get t square minus 17 by 6 whole square. T square minus 17 by 6 whole square. Right. And dx is nothing but what? Dt. Right. Now here you got this expression. Right. Now it is in which form now? It is in this form. Integration of 1 by x square minus a square dx. It is in this form. Instead of x we have t. Instead of a we have what? 17 by 6. What is its formula? 1 by 2a log of mod of x minus a by x plus a plus constant of integration c. Right. I will use that formula here now. I equals to 1 by 3 as it is and into 1 by 2a. 1 by 2 into a is nothing but 17 by 6. Right. Log of mod of x minus a. Instead of x we have t here, right? So t minus a is nothing but 17 by 6 divided by t plus 17 by 6 plus constant of integration. I will take it as c1. Okay. Now here you see 2 ones are 2 threes are 3 and 3 cancel. What do you get? You get 1 by 17. Right. So I equals to, we got what? 1 by 17 log of mod of t minus, I will write it here. Okay. So t minus 17 by 6 divided by t plus 17 by 6 plus constant of integration c1. Till now we have got. Now what to do? You have to substitute the value of t. Value of t is nothing but what? X plus 13 by 6. I should substitute that. So what I will do is, I'll just erase this part. Okay, I'll just erase this part. Okay, what we have? I equals to, we have 1 by 17 log of mod of, we have t minus 17 by 6 divided by t plus 17 by 6 plus constant of integration c1. Now I equals to 1 by 17 log of mod of, what is the value of t? T is nothing but what? X plus 13 by 6. I will write here x plus 13 by 6 minus, this is 17 by 6 as it is, divided by here, what is the value of t? X plus 13 by 6 plus 17 by 6, right, plus constant of integration c1. Now I equals to 1 by 17, now log of mod of, see here, take the LCM. LCM here is 6, here also LCM is 6. So if you take LCM, what do you get? 6 is a LCM. I multiply by 6 here, 6x plus 13 minus 17, right, whole divided by, here if you take the LCM, again LCM is 6 here, 6x plus 13 plus 17, right, plus constant of integration c1. 6 and 6 get cancelled. So what do you get now? I equals to 1 by 17 log of mod of 6x, 13 minus 17 is nothing but minus 4. right, minus 4 divided by 6x. 13 plus 17 is nothing but 30 plus constant of integration c1, right. So what I will do again is 1 by 17 as it is, log of mod of, here I can take 2 common, we get inside what, 3x minus 2. Here I can take 6 common, inside we get what, x plus 5, right, plus constant of integration c1. Now 2 ones are 2 3s are, right. I just need to simplify still, so I'll erase this part now. Right. See, what I will do is I equals to 1 by 17 log of, see here, whatever you have got 3x minus 2 by x plus 5, that I will consider it as m. You know the formula, log m by n. Log m by n is what? Log m minus log n. Right, log m by n is nothing but log n minus log n. So what I will do is, here I will consider this part as m and divided by 3 as n. So what do you get? Log m divided by n. Log m by n is nothing but what? Log m minus log m. So if I apply that formula, log m is nothing but what? 3x minus 2 by x plus 5. I write here 3x minus 2 by x plus 5 minus log n. N is nothing but what? 3 plus constant of integration c1, right. Now I equals to, now multiply 1 by 17 inside to both the terms. What do you get? 1 by 17 log of mod of 3x minus 2 divided by x plus 5 minus 1 by 17 into log 3, 1 by 17 into log 3 plus constant of integration c1. Now I equals to 1 by 17 as it is, log of mod of 3x minus 2 by x plus 5 as it is. Now log 3 is a constant, so this whole term is constant. Minus 1 by 17 log 3 plus c1. Together both I can write as constant of integration c, right, where c is what? Where c is minus 1 by 17 log 3 plus c1, right. Now this is the solution of what? The given integral. Okay, so here the problem is, solving a problem doesn't take much time. It takes a lot of time to what? Simplification steps, right. Now let's see the second problem. Second problem, integration of x plus 2 by 2x square plus 6x plus 5 dx. Okay, so let's consider this integral as I, integration x plus 2 by 2x square plus 6x plus 5 dx. So in all the problems we have solved till now, the numerator was 1. It did not involve what? The x terms. But here the numerator involves x terms. So in such case, what I should do? So what I will do is, I will call this as equation 1. Okay, now I will take this value x plus 2 by 2x square plus 6x plus 5. I will take this and I will express this value in this form, a into d by dx, or we'll do one thing. Instead of taking denominator, I just take the numerator. Okay, I just take numerator x plus 2. Okay, I express this numerator x plus 2 as what? A into differentiation of denominator. Differentiation of denominator is what? 2x square plus 6x plus 5. That is the denominator. A is some constant a into differentiation of denominator plus some more constant b, some another constant b. So what I am doing is a into differentiation of denominator plus some other constant b. Now see here, x plus 2 equals to a into, differentiate this, 2x square differentiation 4x plus 6x differentiation 6 5 is a constant, its differentiation 0, plus constant of, one more constant, we have what? B. Right. Now what I will do is, I'll call this as equation 2. Okay. Now here I will solve for what? The values of A and B. For that, what I will do is, I will substitute 4x plus 6, whatever we have here, I will substitute that as 0. Put 4x plus 6 equals to 0, or plus 6 that side, minus 6. What do you get? X equals to minus 6 divided by 4. Plus 6 that side, minus 6, then divided by 4. Now 2 2s are 2, 3s are. It's like substituting x equals to minus 3 by 2. Right. So I'll just do one thing. I'll just write it here. Now put this x equals to minus 3 by 2 in the equation 2. Okay. Or let me write put. No problem. Right. Put x equals to minus 3 by 2 in the equation 2. So if you substitute x equals to minus 3 by 2 in the equation 2, let's see what happens. X is minus 3 by 2 plus 2 equals to a into this 4x plus 6 is nothing but what? 0. That's how we got x equals to minus 3 by 2, right? 4x plus 6, whole thing is 0. I'll write it 0. Plus b I will write. Right. Now a into 0, 0. So leave this 0 plus b, b. So what do you get? B equals to, now see here, take LCM. 2 2s are 4. 4 minus 3, 1. So b equals to 1 divided by 2. So we got the value of b as what? 1 by 2. So that's how we found the value of b. Now to find the value of a, you substitute any other value of x. Let's take, let us substitute or put x equals to, let's say 0. Put x equals to 0 in the equation 2. You can substitute any value of x you want. Okay, I will substitute x equal to 0. 0 plus 2 equals to a into 4x. 4 into 0 plus 6. 4x plus 6, right? X value is 0, right? Plus b. Now 0 plus 2 is 2 equals to a into 4 into 0, 0. 0 plus 6, 6. So we get what? 6a plus b. Right. Now what I will do? 2 as it is and plus b this side, minus b equals to 6a. 2 minus, what's the value of b? B is nothing but 1 by 2 equals to 6a. Right. Now 2 2s are 4. 4 minus 1, 3. So we get what? 3 by 2 equals to 6a. Now here you can see 3 1s are 3 2s are. Now take 2 here. Now a equals to 1 divided by 2 2s are what? 4. So we got the value of a as what? 1 by 4. And we got the value of b as what? 1 by 2. So using that, so let me call this as equation 3 and I'll call this as equation 4. Now substitute equation 3 and equation 4 in the equation 2. Right. Now put equation 3 comma equation 4 in the equation. So yeah, in the equation 2. Right. So what do you get? X plus 2 equals to a into 4x plus 6. A is nothing but what? 1 by 4. 1 by 4 into 4x plus 6 plus b, right? Plus b. B is nothing but what? 1 by 2. Right. Now we simplified this. We found the values of a and b. This value, x plus 2 equals to this. I need to substitute in the equation 1 now. Okay, I'll call this as equation 5. Okay, so let us substitute equation 5 in the equation 1. So what I will do is, I'll just erase this part. Okay, I'll just erase this part. Here I will write, put equation 5 in equation 1. Put equation 5 in equation 1. So what do you get? I equals to integration x plus 2 is nothing but what? 1 by 4 into 4x plus 6 plus 1 by 2 whole divided by what? 2x square plus 6x plus 5 dx. Right, I have substituted the value of x plus 2 as this. Right, now I will erase this part also. Okay, now let's simplify this. Now how to simplify this is I will split the integral. Now see here, I equals to, what I will do is I will split and write integration 1 by 4 into 4x plus 6 divided by 2x square plus 6x plus 5 dx plus integration 1 by 2 divided by 2x square plus 6x plus 5 dx. I am splitting the integral and writing it. I am taking 1 by 4 into 4x plus 6 in the first integral, 1 by 2 in the second integral. Now I equals to, what I will do, I will take 1 by 4 outside and inside I write 4x plus 6 divided by 2x square plus 6x plus 5 dx plus I will take 1 by 2 outside, we get what? Integration 1 by 2x square plus 6x plus 5 dx. Right, now I will take this integral as I1, this integral as what? I2. Now see here, I equals to 1 by 4 times I1 plus 1 by 2 times I2. I call this as equation 6. Okay, so what is I1? I1 is nothing but this integral. What is I2? This integral. See, I'll write here where I1 equals to integration of what? 4x plus 6 divided by 2x square plus 6x plus 5 dx, and I2 equals to what? Integration 1 divided by 2x square plus 6x plus 5 dx. See, I have taken this integral as I1, this integral as I2. Now I will solve for I1 and I2 separately. Right, what is I1? I1 is given by integration of 4x plus 6 divided by 2x square plus 6x plus 5. Right, so here I will use substitution method. So what I will substitute? See here, 4x plus 6, is it not differentiation of this? Because we have expressed that a into d by dx of this, right? A into d by dx of denominator is nothing but this term. So it means I will substitute, put 2x square plus 6x plus 5 as some constant or as some variable t. Now differentiate with respect to x. Differentiate with respect to x. Differentiate with respect to x. See, this I am substituting as t. Differentiate with respect to x. 2x square differentiation. 2 2s are 4x plus 6x differentiation 6. 5 is a constant, its differentiation 0 equals to t differentiation dt by dx. Now dx into this, what do you get? 4x plus 6 into dx equals to what? dt. Right, so we got what? 4x plus 6 into dx is nothing but dt. This I will substitute in this equation. It means what is your I1 will become? I1 will become what? What's your I1 now? 4x plus 6 into dx. 4x plus 6 into dx is nothing but dt divided by 2x square plus 6x plus 5. That is nothing but what? T. So this we can write what? I1 equals to integration of 1 by t dt we can write. What is integration of 1 by t? Log of mod of t. Log of mod of t. Right. Now log of mod of t. What is log of mod of? What is t? T is nothing but 2x square plus 6x plus 5. So 2x square plus 6x plus 5. Right. This is the value of I1. Right. See here I will write the value of I1. I1 equals to log of mod of 2x square plus 6x plus 5. Right. We got the value of I1. So let us solve it for what? I2. So to solve it for I2, I'll just erase this part. I'll just do one thing. I'll just write this equation here because I need it later, or let me write it here. I need it later. I equals to what we have? 1 by 4 I1 plus 1 by 2 I2. Okay, I'll write plus constant of integration C also here. Better. I'll write plus constant of integration C. That is nothing but what? Equation 6. Right. Now whatever the value of I1 I have got, I will write it here. I1 is nothing but what? Log of mod of 2x square plus 6x plus 5. I will call it as equation 7. Right. Now let's solve for what? The value of I2. We got I1. Let's solve it for I2. So I'll just erase this part. I2 is nothing but this integral. Right. I will write it here. So I'll solve for I2 now. I2 is nothing but what? Integration 1 by 2x square plus 6x plus 5 dx. Such problem we have solved, in the same session we have solved the first problem. It is similar to this. We have coefficient for x square here. So what I should do? Take 2 common, right? So if I take 2 common in the denominator, integration 1 divided by, if I take 2 common here, I get x square plus here I get 3x, because 2 into x square, 2x square, 2 into 3x, 6x. So here I get 5 by 2. 2 and 2 cancel, we get what? 5. And I write what? Dx. Now you should use what? Completing square method. To use completing square method, I should use a plus b whole square. Why? Because coefficient of x is what? Positive here. See here I will write a plus b whole square. It's given by what? A square plus 2ab plus b square. So if you compare, a square is nothing but what? X square. 2ab is nothing but what? 3x. So you compare. So I'll write here I2 equals to 1 by 2 integration 1 divided by x square plus this I will write in the form of 2ab. 2 into a is nothing but x, and here I should write some term such that I should get 3x. See here I have 2, I have to cancel that 2 because in the denominator I have nothing here for 3x, right? So 2 and 2 cancel, but I should get 3x, so I will write 3 here, right? A square plus 2ab, right? Now I should add and subtract b square. B is nothing but 3 by 2. I will add 3 by 2 whole square, I will subtract 3 by 2 whole square, and then plus 5 by 2, and I write what? Dx. Right. Now what is I2? I2 is nothing but 1 by 2 integration 1 divided by a square plus 2ab plus b square. Is it not a plus b whole square? So x plus 3 by 2 whole square minus 3 square is 9, 2 square is 4, plus here it is 5 by 2. I write what? Dx. Now here I2 equals to 1 by 2 integration 1 divided by x plus 3 by 2 whole square. Now minus, what's LCM of 4 and 2? LCM of 4 and 2 is 4. Now here you multiply with 1, here you multiply with 2. 9 1s are 9, 5 2s are 10. 10 minus 9, 1. So I get plus 1, and I write what? Dx. Now here 1 by 4. How can I write 1 by 4? 1 by 2 whole square. See, I will write here I2 equals to 1 by 2 integration 1 divided by, this is x plus 3 by 2 whole square, x plus 3 by 2 whole square plus 1 by 4 we can write as what? 1 by 2 whole square dx. Now what you will substitute x plus 3 by 2 as what? I will substitute, put x plus 3 by 2 as some other variable u, because I have taken t in the previous case. I have taken what? U here. Now differentiate with respect to x. Differentiate with respect to x. What you get? X differentiation 1, 3 by 2 constant differentiation 0, u differentiation du by dx. Now dx into 1, dx equals to du. Right. Now if you apply the formula, if you apply these values, what do you get? 1 by 2 as it is, integration 1 by x plus 3 by 2 is nothing but u. We get u square plus 1 by 2 whole square, 1 by 2 whole square, and dx is nothing but du. Dx is nothing but du. Now I2 equals to 1 by 2. Is it not in the form of what? Integration of 1 by x square plus a square? See here I will write, because integration of 1 by x square plus a square dx is nothing but what? 1 by a tan inverse x by a. Right. We have this formula 1 by a tan inverse x by a. So if you compare here, x is nothing but u. Right. A is nothing but what? 1 by 2. So if I apply the formula 1 by a is nothing but 1 by 2 tan inverse x by a. Instead of x I have u divided by a is nothing but what? 1 by 2. Now here you see 2 and 2 cancel. I2 equals to 1 into 1 is 1, so I will leave it. Tan inverse, this 2 goes up, right? We get 2u, right? 2 times u, but what is u? X plus 3 by 2. So 2 times x plus 3 by 2 we get. So I2 is nothing but what now? Tan inverse, multiply inside, 2 into x, 2x plus 2 and 2 get cancelled, and we get what here? 3. So we get what? I2 as what? Tan inverse 2x plus 3. We called this equation as 7. I will call this equation as what? 8. Right. Now we got the values of I1 and I2. You substitute these values of I1 and I2 in the equation 6. I'll just erase this part. Substitute or put equation 7 comma equation 8 in the equation 6. So I equals to 1 by 4 times I1. I1 is what? Log of mod of 2x square plus 6x plus 5 plus 1 by 2 times I2. I2 is what? Tan inverse 2x plus 3, right, plus constant of integration c. That's the solution for this problem. Okay, this method involves what? Solving by substitution as well as using the the derivations we have done.